we're back. So again, chapter 6 is all about exponents and properties of exponents and exponential functions, all sorts of things, okay? So we're going to get into something that will be a little bit different. Some of you guys might find this more difficult. Some of you guys might think this is easier. Basically, what we're going to be doing with this first part of chapter 6 is a lot of learn the rules, apply the rules. Okay, learn the rules, apply the rules. And I was actually surprised to find out. I was talking to Mr. Spottelson about this, and he was like, Mr. Spottelson and Mr. Rutin, and they both said like, oh, we like teach them all of those rules. I was like, really? Because every year, like my students come in and it look like they've never seen this before. And I'm going to teach it the exact same way. I'm going to teach it like you guys have never seen this before. But I was surprised to find out like, oh, you guys do have a little bit of history with this stuff. So it shouldn't be brand new. It shouldn't be brand new. All right. Now, that being said, the homework assignments for these sections, you may, like if you look up at the board and you say, oh, 1 to 25 odd, man, that's a lot. That might seem like a lot. I will say this. You know, if I asked you to do 1 to 25 odd and they were all graphing problems, you would throw something at me, right? Because that's a lot. But these are not all graphing problems. Like last chapter, one problem might have taken you. Yes, scoot your desk up a little bit. For some reason, they just keep moving back. Like one problem may have taken you 3 or 4 minutes to do in chapter 5. That's not the case anymore. One problem is probably going to take you like 30 seconds to do, if that. Okay, if you know what you're doing. If you need to look back and look at your notes and see what the rules were, well, then that might take you a little bit longer. But the more you work with this stuff, the better you're going to remember the rules. Now, I'm going to teach you a bunch of rules today and tomorrow, a bunch of properties today and tomorrow. Here's the deal with that. I mean, you have to memorize these properties of exponents that we'll talk about today and tomorrow. But the more you work with them, the more you do your homework assignments, the more they're just going to stick in your brains. Okay? So again, I know I sound like a broken record. I cannot stress homework enough. Because the more you do your homework, the better you will be at remembering and memorizing these properties. If you don't do your homework, nothing's going to stick. I promise you. Okay? You've got to do your homework to try to get this to sink in a little bit. Now, to introduce properties of exponents, we're going to talk about a bunch of properties, a bunch of rules to follow. Today, how we're going to start out this is talk about the powers of 5. You know, before we start that though, let's talk about what a basic exponent is. Like at the root of it, by definition, what is an exponent? Well, it's really just repeated multiplication. Like if you think about 3 squared, 3 to the second power, that's just taking the base of 3 and repeatedly multiplying 2 times, right? 3 times 3. If I took 3 to the 4th power, I would just be taking that base multiplied by itself 4 times. 3 times 3 times 3 times 3, right? Whatever the base is, you just repeatedly multiply the exponent number of times, right? So let's take a look at this table that you see on your papers as well. Now, on your papers, it kind of gives it away, but there's a pattern. There's a pattern that you see in the values. What's the pattern that we might be able to see? Gio?
Times 5.
Instead of timesing, dividing by, going from left to right.
Oh.
Right? I'm dividing by 5 each step. You may not be able to see it from 3125 to 625, or maybe even 625 to 125. But you can see it from 125 to 25. 125 divided by 5 is 25. 25 divided by 5 is 5. These are the powers of 5. If I actually went to my calculator and calculated 5 to the 5th, 5 to the 4th, 5 to the 3rd, 5 squared, 5 to the 1st, obviously is 5. So let me ask you, based on this pattern, if I continue this pattern, what should 5 to the 0 be?
0.
No.
What?
1.
Because it's 5 divided by -5.
Yeah, because it's divided by 5, right? 25 divided by 5 is 5. What is 5 divided by 5? 1. And that's why anything to the 0 power is not 0, but 1. Anything raised to the 0 power is 1, always. And I could do this with any base. I could make this table with 3s, or 7s, or 2s, or any negative number as well. Okay. Now, what if I kept that going? What if I kept that going? Because somebody said to me, oh, like I think somebody first period said to me, oh, that's easy. That's going to be negative 10. 5 to the negative. They were like, oh, it's going to be negative 10. Hold off on that. What do you think 5 to the negative first is going to be?
1/5.
1/5. That's true. 1/5. Why? Because I'm dividing by 5. Is there any negative number going on? No. The only thing negative was the exponent. And I need to stress to you right now, I'm going to say this a million times and I'm going to try to beat it into your head. Negative exponents do not mean negative numbers. Negative exponents mean fractions. Negative exponents do not necessarily mean negative numbers. Negative exponents mean fractions. Let me show you what I mean here. What do you think that's going to be?
1/20.
No, it was right. 1/25. 1/25.
So pretty much it's the same exact thing going the same way, you just put a 1 on top.
Okay, so now that's why I wrote the rest of this on the board here. We talked about 5 to the negative 1 being 1/5, 5 to the negative 2 being 1/25. What if I kept this going? 5 to the negative third.
1/20.
1 over
1/25.
1/25. What about 5 to the negative fourth?
1/625.
1 over 625. So what's the rule then for a negative exponent? Shift it down, turn it positive, right? Shift it down to the denominator, leave a 1 in the numerator, and make it a positive x. Give me the positive version of that exponent, okay? Which is what you see down below, okay? I would box this here and this here. That's the 0 exponent property and the negative exponent property. Okay, so for any non-zero number, anything raised to the 0 power is 1. You know, actually, it's funny that the book says this, that the power of 0 to the 0 is undefined. Because I actually have done a little research on that. I looked up last year, I think maybe 2 years ago. I looked, and there's actually still some debate on what 0 to the 0 power actually is. Some people say it's 0. Some people say it's undefined. But there's still some argument there. So it's funny that this book actually says it's undefined. I would use the term undetermined because there's still some argument to it. But anything non-zero raised to the 0 power is 1. 20 to the 0 power, 1. 5x to the 7th to the 0 power, 1. Mr. Laverick to the 0 power, 1. X to the 0 power, 1. Anything non-zero raised to the 0 power is 1. Now, for any negative exponent, again, negative exponents do not mean negative numbers. Negative exponents mean fractions. That's why you see here 4 to the negative second power becoming 1 over 4 to the positive second power. So all that negative does is hits the elevator button down and goes down to the denominator and turns positive. 1 over 4 to the positive second power. We could make that 16 if we wanted to. So in terms of my letters here, in terms of my algebraic property, a to the negative nth power, well, I just make that negative positive and I put it down into the denominator. Negative exponents mean fractions, not negative numbers. All right, let's do some examples of this. So I've got 4 to the negative third power. 4 to the negative. Now, look what it says up in red up top. No decimals. I don't want you guys just going, oh, 4 to the negative third power, and then just giving me that decimal. I will not accept that decimal. I want it as a fraction.
1/64.
How'd you get that?
Well, I typed in my calculator 4 to the negative third power.
And then you did fraction and decimal.
Correct.
I would like you to do it like this.
4 times 4 is 16.
Hold on. I would like you to do it like this. 1 over 4 to the positive third power. Write it like that. Because can you plug in variables into your calculator? No. You're going to need to know how to work with the property, and I'm just showing you how to do it with the numbers so that when you do have letters, it doesn't freak you out. So this is like saying 1 over 4 to the positive third power. Which 4 to the third power is 64? So I'll actually be looking for two things. I'll be looking for this, and I'll be looking for this. They're equivalent statements, but I want to see that. I want to see you using the property to reduce it and then give me the final number.
Do you want us to write both?
Yes, please.
All right.
Let's do that again. Okay, what's anything to the 0 power?
1.
Okay, that's an easy one.
Boom, check.
No pun intended. That's an easy one.
Remind me to laugh later.
Okay. Now, take a look at C and D. Now, I have them side by side. Yours kind of goes down to the next line. What's the difference between example C and D? Parentheses and not parentheses, right? C has parentheses, D does not. Now, remember, what do those parentheses mean? Well, they mean that -5 is my base. Still apply the property the exact same way. Like, because this negative exponent is there, and that's where I'm talking about the negative there. That negative means it shifts down into the denominator. What shifts down? The entire base. And now it's raised to the positive exponent.
-1 6 times.
Be careful here. I then say, what is -5 to the 4th power? Positive 625. Because there's parentheses there, this is a positive 625. So 1 over 625. Yeah.
So hypothetically, like, how did you get this answer? Because like,
Okay, negative exponent shifts it down to the denominator. Okay? And the only thing that happens when it goes down to the denominator is that negative sign goes away. Do you see how that statement and that statement are the same thing with the exception
The
of
exponent is the exponent again. It's not really the denominator.
Shh, guys, stop talking. There are way too. This is a difficult topic, and if there's conversation going on and you don't understand it, you're only going to fall further behind. So the negative exponent becomes positive when I shift it down to the denominator. The negative up there. Now, did you notice how the negative did not go away in the number? That stays. The only reason it shifts down to the denominator is because of the negative exponent.
It just stays because of the parentheses, correct?
It'll stay even if it's not.
So now is the negative.
That is a negative 625.
Sure.
So 1 over negative 625. And again, some of you are going to need more work on this than others. Some of you guys are going to be like, oh, this isn't so bad. Some of you guys are like, you're talking Japanese to me. Okay. Now let's take a look at these two, E and F. Again, the only difference is that parentheses, right? So it doesn't matter when there's a 0 exponent. Tommy, what's the answer to E?
Answer to E, 1.
1. You had raised your hand. I would assume you wanted to answer it, right?
I'll stretch.
Oh, you raised your hand. I saw you. You were like, ooh, Mr. Evans, ooh. Just give me one of those.
And you said
1. Now, let me ask you, what is the answer to F?
-1.
Ah, I'm glad we said -1. Yeah. Because what's being raised to the 0 power?
A negative number.
What's being raised to the 0 power? Just the 5. 5 is being raised to the 0 power. So that's the only thing that turns to 1. The negative has to stay out front. Okay? So that's our 0 exponent property and our negative exponent property. One last thing about our negative exponent property is that if you have a negative exponent that's already in the denominator, I just got done talking about how a negative exponent shifts it down, right? If you've got a negative exponent that's already down in the denominator, where do you think it goes? Up. Exactly. So if you have something like x squared over y to the negative third. If you have something like x squared over y to the negative third, because this negative exponent is already in the denominator, this shifts upward to become x squared y to the positive third. Now, do I need that over 1? No, I don't need that over 1. It would just end up being x squared y to the third. Okay? So, moral of the story is, if you've got a negative exponent, it moves. If you've got a negative exponent, it moves. If it's in the numerator, it moves down. If it's in the denominator, it moves up. It's got to change positions. It's got to change orientation. Okay? So let's take a look here. 7w to the negative fourth times z. Now, first off, you might be saying, what do I even do to this thing? Well, if there's negative exponents, you have to remove the negative exponents. Negative exponents are not simplified. Negative exponents are not simplified. So I have got to get this negative exponent to go away. That's the piece that's not simplified here. Now let me ask you, what is being raised to that negative exponent? What is my base?
7w.
What is my base?
7
It's not 7,
w.
just w. How do you know the 7 is not part of my base? There's no parentheses around it. My 7 would be in my base if it was like this, but it's not. The only thing being raised to the negative fourth power is the w. Okay? So, what moves down into the denominator?
W.
Just the w. Just the w gets moved down to the denominator. And the exponent becomes positive when it does. Okay, so what does it mean about my 7 and my z? Yeah, we just leave them on the top. We don't move them. They were fine where they were. Like, you can think about it like this, right? There was always a divided by 1 there, right? It was on the top, so leave it on the top. There's nothing that you need to do with the 7 or the z. The only thing that needed to be moved was the w because it was being raised to the negative exponent. And now that's done. How do you know you're done? Because that's a lot of times the hard part about this. You don't see any negative exponents or any zero exponents for right now. We'll add some more things onto that list here in a minute. But for right now, do we see any negative exponents? Nope. Do we see any zero exponents?
Nope.
We're ahead of them by a lot.
That's okay. We gotta get moving.
No, I'm saying like that's good. That means you're the better team.
I know. Oh.
Whoa.
No.
Almost taking shots.
See, like they're behind us.
That's okay. He was probably going over something. All right. So let's take a look here. If you've got this expression, there's a lot of things I need to simplify. Don't you see a lot of negative exponents?
Yeah.
And there's something that I see right off the bat.
0.
What is a to the 0? 1. I'm sorry, I'm boring you so much you keep yawning, Thomas.
Oh, I know.
Don't do that.
But
That wasn't an I know, Noah.
But it's an effect because if you hear someone yawn, you yawn, or like you see someone
Not
yawn, you
contagious.
yawn. Yeah, it is.
Is B? You know how I say this? This is how I describe this. If you've got b to the negative second power, any negative exponent is not happy where it is
That's unfortunate.
because it needs to move. Any negative that's just the way I remember it.
It's because they're negative.
Any negative exponent is not happy. If it's in the numerator, it needs to move down. If it's in the denominator, it needs to move up. So, is b happy where it is? No. It's got a negative exponent attached to it. So, it was in the numerator. I'm going to move it down to the denominator and make it positive. Is c happy where it is in the bottom? No, move it up. It was in the denominator. We need to move it up to the numerator and make it positive. Shh. Stop talking. Is D happy where it is?
Yes.
Yes. So leave it.
Boom.
Now, do I need the 1 there up on the numerator?
No.
No. I mean, no, it's okay if you've got it there. So I'll just box that so I don't have to rewrite the whole thing. Yeah.
Why is the C not happy but the D is happy?
Because
It's
the
positive.
stop talking. Let me explain things. Stop. Just stop. That's so annoying. Tommy, just shut your mouth, man. Thank you. That's all I'm asking. The C was not happy because
But why
it was
is it not happy? Then?
because of the negative. Anything with a negative exponent is not happy.
If it's on the bottom.
Either top or bottom.
All right. So then like
B was not happy either.
that's our answer right there.
That's why B moved down to the denominator.
So like if it's positive, it's happy. But like if it's not positive, like you gotta move it.
You gotta move it.
But then you change the
Exponent positive.
to
Exactly.
All right.
So let's take a look at one more of these.
So, does the A just like go away?
Yes, because it becomes 1. Anything raised to the 0 power is 1. And be careful with that. A lot of people might try to tell me that that's like 1A. No, it just becomes the number 1. X to the 0 power is 1, not 1x. Does that make sense? Okay, take a look at this one. X to the negative 3rd power. Is X happy? No. So it moves down and becomes positive. Is Y happy?
No.
So move it down and make it positive. I'm going to skip 2 for a second. Yeah, you could just write Y if you wanted to. I'm going to skip the 2 for a second. Is A happy? Yeah. So leave it. Don't move it. It's happy on the bottom. Okay. Is negative 2 happy?
No.
Yes.
Maybe.
I don't know.
Yes. It's happy.
No one knows how, but it just sounded
Stop talking, Noah. Gosh. You just talk to them every time I say something like that.
I answered your question.
You celebrate how we got right.
Now, why is it happy where it is? Because the exponent on negative 2 is positive. Like think about what the exponent on negative 2 is. Positive 1. Positive 1. If that were a negative exponent, then it would move. Don't confuse a negative exponent with a negative number. The number was negative. The exponent is positive. The number was negative. The exponent is positive. Can anybody tell me what I leave on the top? A 1. If everything shifts down to the denominator, you need to leave something in the numerator, so we leave a 1 in the numerator. Okay, so that was negative exponents, 0 exponents. Let's talk about our product properties. We're going to talk about product, quotient, and power to a power on the back here. Now, you do not have this page on your actual sheet right now, so everybody look up at the board. I'm going to introduce this to you by showing you powers of 2. Everybody look up here, please. I've got 2 to the 4th times 2 to the 5th. Said, hey. 2 to the 4th times 2 to the 5th. Here's 2 to the 4th. Isn't 2 to the 4th 2 repeatedly multiplied 4 times?
Yes.
Isn't 2 to the 5th, and then it's times 2 to the 5th. 2, 3, 4, 5. This was 2 to the 4th. This was 2 to the 5th. So what do you think 2 to the 9th is? Tommy? Oh, shoot. I said the answer. Yes, what's your question? Which question?
Could you just switch it around? Like 5 times 2, 4 times
2 to the 5th.
No.
2 to the 4th. It's not 2 times 5 and 2 times 4. 2 to the 5th. 2 to the 4th.
And
So-
then we equal.
So what do you think 2 to the 4th times 2 to the 5th is? 2 to the 9th. I kind of let the cat out of the bag a little bit there. How do I know that? 1, 2, 3, 4, 5, 6, 7, 8, 9 twos, right? And then we see what could we have done with the exponents? And that's the rule for property of a power. Yes.
If we're adding the exponents, then why is it a multiplication sign?
Because multiplication of my bases means addition of my exponents. Because how many twos are actually there? 9. And 2 to the 9th is the power.
Wouldn't you multiply the base then?
No, I wouldn't need to. Because like 2 to the like think about it. What is 3 squared? 3 times 3, right? Not like 9 to the second, isn't it? You know what I mean? You don't do anything with the bases. Just like, think about it like combining like terms. Like you have 2x plus 7x. You're going to make that 9x squared? No, you're just going to make it 9x. You know what I mean? Yeah.
If we wrote down 81, would that still be correct?
No. Well, it's not 81, but you would want to give it to the number. You want to make the number as well, though. I'll show you what I mean here in a second. So this is your property. Everybody write this down in your pages. A to the m times a to the m is a to the m plus n. To your point, you do, whenever it's just a number, you do want to get it to just being the number. No, we're up here.
Oops.
Yep. This is the top of the back. A to the m times a to the n is a to the m plus n. So what am I saying here? I'm saying that if I am multiplying with my bases, I add within the exponents. If you multiply within the bases, you add within the exponents. So what do you think my final power on x is? X to the 5th, yeah. Multiply with my bases, so I add the exponents up top. Okay, let's do some examples with that. Okay, 3 squared times 3 to the 5th. What would that be? As just a power. No? 3 to the 7th. Now, this is the question Kenny was asking. Yeah, let's actually do 3 to the 7th. 3 to the 7th is 2187. Again, I'll look for both of these. Because it's about reducing the exponent. Now, if you've got Q's and R's going on, like look at the next example. We've got Q to the 3rd, R squared, Q to the 6th. Okay, what's my final power on Q then? Yeah, you just basically combine like terms. Q to the 9th times R squared. There's my answer. And let's take a look at our last one here, example C. What's my power on n on the far right? N to the 1st, right? Okay, so what does that tell me about my final power on n? Assuming, with all of the negatives and everything. Good, it would be 0. What does that tell me about my final answer? Yeah, what's it? It's 1. Yeah. Questions about that? Okay. So yeah, again, reduce as much as you can, but if you, in the end you've got a 0 power or negative power, you've got to work with it. You got to simplify it. All right, we got our quotient property now. Now, what does quotient mean in terms of a operation? Division, right? Quotient means division. I'm going to show it to you using these powers of 3. 3 to the 5th over 3 to the 3rd. Well, remember, that's like this. Here's 3 to the 5th. Here's 3 to the 3rd. What can I do with my 3's? Oh, if they're top to bottom, can't I cancel those 3's? Right, I can cancel out common factors, leaving us 3 times 3 or 3 squared. What do you guys think my shortcut is for quotient property? Subtract. Which makes sense. My multiplication property was add, so my division property is subtract. And that's the property that we have. Go ahead and write this down. A to the m divided by a to the n is a to the m minus n. So when you're talking about division, that's subtraction of the exponents. Yes?
So the bases are like division and multiplication, and the exponents are addition.
Yes. Yeah. Don't confuse it with what's happening with the bases. And again, the bases always have to be the same. Just like we couldn't combine those Q's and R's. The bases have to be the same to apply these properties.
So it's just the same thing, but multiplication is adding and then division is subtracting.
Exactly.
So an x would be 5.
So this is going to be x to the 5th. 7 minus 2 is 5. Always top minus bottom, even if that implies getting a negative. If it implies getting a negative, then you have to shift it back down to the denominator in the end. Okay, let's do our examples for this set. Okay, this is like the exact same thing that I had just a second ago. I should have changed this example. 7 over 2. Oh, really? 7 over 2? So this ends up being 2 to the 5th. Now, I guess this is another good example to show that if you've got a number, if it's 2 to the 5th, just give me the full value. 2 to the 5th is 32. But again, I would look for both of those. Yes?
2 to the 25.
No, that's 5 to the 2nd.
Oh, yeah.
Yeah. All right, so what would this be? X to the first, right? X to the 4 divided by x to the 3rd is x to the 1st power. Or just x if you wanted to. That's fine too. Okay, now let's take a look at this next one. This one's a little tricky. First off, let me ask this question. What's my power on 3 right here? It's not there. 1. Always remember that if you don't see an exponent there, the power is 1, even if it's on a number. So let me ask you, what is the power on 3? Notice we're going to do that same thing where we were like combining like terms. We're going to do that exact same thing. What's my power on 3?
2.
Negative 1. Be careful with that. Top minus bottom. 1 minus 2
I thought you were asking
is negative 1. What's my power on 4? Another negative 1. 3 minus 4 in the exponents. Another negative 1. And what's my power on 5? 2. 5 minus 3 is 2. Now, can I leave it like that? No. I see negative exponents. What do I have to do with those negative exponents? Move them down. They hit the elevator down button. They both go down to the denominator. 3, not happy where it is. Move it to the denominator. 4, not happy where it is. Move it to the denominator. Is 5 happy where it is?
Yes.
So leave it. Okay, so that's simplified down. Let's actually evaluate it though. Like for example, what is 5 squared? Nathan, what's 5 squared again? 25, there it is. 25. And then on the bottom, that's just 3 times 4. So 12.
So
Yes, Simon?
So after you put it on a bond, you just make it just regular 1. And just
Yeah, since it's an exponent of 1, it's just that number. Yeah.
Let's say like it was 24 with 12, but we simplify it over.
Yeah, you should simplify it if you can.
Alright.
Like these, they don't have any common factors, so you know. All right, last property that we'll do today is called the power of a power. Okay, so this is like an exponent on an exponent. This is an exponent on an exponent. So this is 4 to the 3rd to the 2nd. 4 to the 3rd to the 2nd. Now, to illustrate this one, I'm going to show you this. Now, doesn't that to the 2nd power just mean multiply this thing over on itself 2 times? So like 4 to the 3rd times 4 to the 3rd, right? That's 4 to the 3rd squared. Well, multiplication of the bases tells me to do what to my exponents? Addition, right? So 4 to the 6th. Can anybody tell me the shortcut to go from here to here?
4 times 2.
Multiplication, 3 times 2. Multiplication. That's the property. Go ahead and write that in. A to the m to the nth power is a to the m times n. Go ahead and write that in on your papers there. A to the m times n. There's no operation in there, but you assume that that's multiplication. A to the m to the nth power is a to the m times n. So what's my power on x here? 12. X to the 12th. Yeah, you. That's what I said at the beginning of class. You definitely did this last year in Math 8. Do you remember it?
No.
Maybe not.
Yes.
But at least it's somewhere back there. Okay, what is this? 5 to the what power? 8th power. Now, I simplify it, and now let's evaluate it. Since it's just a number, let's evaluate it. Now, that's going to be a pretty big number. 390,000.
And it said 3. I thought it said 8.
625.
Wait, hold up. 390?
Yeah. 5 to the 8th power. You guys are going to find throughout this chapter, that's what's unique to exponents and exponential functions. They will grow very fast. Exponential functions will either get really big fast or really small fast. So just increasing the exponent just to the 8th power makes us have a really pretty big number. Okay, don't overthink it. 1. Anything raised to the 0 power is
1.
even 4 to the 3rd to the 0 power. 1. We could illustrate this by saying, well, what is 3 times 0? 0, which ends up being 1 anyway. Okay. Let's take a look at example C. Let's go with our order of operations here. Let's do our exponent first before we do our multiplication. What is x to the 3rd to the negative 5th, Brendan? X to the negative 15th. And then we have times x to the 4th.
So 11.
X over 4 divided by x to the...
I like where you're going, but let's add them first before I do that.
11.
Negative
Sorry.
11.
I said 11.
X to the negative 11. And now we shift it. See, what Nathan was trying to do beforehand, he was like, oh, I want to get that negative exponent out of the way. Combine it first, then deal with the negative. Because this negative is telling me to do what?
Go down.
Take the elevator down. So 1 over x to the 11th.
Wouldn't it just
Stuff
be
pretty
1?
easy so far.
Oh wait, no.
You good?
My bad.
Don't know why I'm doing it.
Shh. Last one here. What is a to the 3rd to the 4th? A to the 12th. What is a to the negative 2nd to the negative 3rd? A to the positive 6th. So you might have tried to like put something in the denominator there. Would I have needed to do that? No.
8 to the 16. 18.
A to the 18th. Okay, so we're going to start creating a list for ourselves of all of these properties. Like we had a 0 property. Anything to the 0 power is 1. We had a negative exponent property. Any negative exponent, we shift it down or up, depending on where it was to begin with. We have, quiet folks, come on, recapping, be quiet. We had our product property, where if we multiply with the bases, we add the exponents. We had a quotient property, where if I'm dividing with the bases, I subtract the exponents. And we have a power to power, which means we multiply the exponents. Okay? I cannot stress it enough. The more you do your homework, the better you will remember these. Do you have to like sit and make flashcards of all of these? You should never have to do that, because you will be, if you do, sincerely do, not just copy from someone, but if you sincerely do your homework night to night, problem to problem, these will just get stuck in your head. You won't have to memorize them. They'll just be in there. Just stay seated till the bell rings, please.